A chemical compound, it consists of various types of element in it. And when we describe the mass of an element with relative to the mass of the entire compound, then it is known as the percentage of composition. So for an example, if a substance were to have a generic formula of AXEY, so here in this case, we can see that this compound, it consists of element A and element E. So there are two different elements that make up this compound. To describe how much percentage of it is the element A, we will be able to calculate that by doing the following. Taking the mass of the element A and divided by the mass of the entire compound and express that as the percentage. For an example, the percentage of the element A by mass would then equal to X multiplied by the mass of the element A divided by the total mass of the entire compound multiplied by 100. And similarly, we can also calculate what is the percentage by mass of the element E, which then equal to Y multiplied by the mass of element E divided by the total mass of the entire compound multiplied by 100. So that is how we will be able to calculate what is the percentage by mass of an element in the compound. And again, it can be done by taking the mass of an element of our interest divided by the total mass of the entire compound. Now, the percentage by composition is also called the percentage by mass. They refer to the same thing. And in addition, they are very similar to the concept of the mass ratio. So overall, the mass ratio or the percentage of composition or the percentage by mass refer to the same thing. They convey similar amount of information. For an example, calculate what is the percentage of fluorine in calcium fluoride. So the question is asking for the percentage by mass of fluorine. And again, if we were to see this with percentage right here, we should be thinking of percentage by mass. So what would be the mass of fluorine in calcium fluoride? So in this case, to calculate the percentage by mass of fluorine, this is then equal to 2 multiplied by the mass of each fluorine, which is 19.00 gram per mole, divided by the total mass, which then equal to 2 times 19.00 gram per mole, plus the mass of calcium, and in this case, 40.08 gram per mole, and multiply this by 100. So we will be able to get 48.67 percentage of fluorine. So what this means is that fluorine is 48.67% by mass. And if we were to ask you for the percentage by mass of calcium, then in this case right here, we will be able to set up the equation as follows. The percentage of calcium would then equal to the mass of calcium divided by the total mass. And the mass of calcium in this case right here is 40.08 gram per mole divided by the total mass, which is 2 times 19 plus 40.08 multiplied by 100. And now we would have 51.33% calcium. So that's how easy it is to find the percentage of composition of any element in a compound. But more importantly, it's very important that we know how to use the percentage by mass as a conversion factor. Yes, this information right here are conversion factor. Anytime we have the percentage of something, this is how we can use it as a conversion factor. So if we were to have the percentage, we can now assume on the denominator it be 100, exactly 100 of the total. And in this case, the entire compound is in calcium fluoride. So what this means is that 100 gram of calcium fluoride. And on top, it then be 48.67 gram of fluorine. So that's how we can use this as a conversion factor. Gram of fluorine over the gram of the entire compound. And in this case, 100 gram on the denominator. That's how we can convert the percentage into a set of conversion factor by having 100 of the total on the denominator. And similarly, if we were to have 51.33% calcium, what this means is that for every 100 gram of the entire compound, calcium fluoride, there will be 51.33 gram of calcium in it. So again, this percentage of composition right here show the relationship between the mass of an element to the mass of the entire compound. And this is why that is very similar to the percentage to the mass ratio. Because when we have learned how to find the mass ratio already, we will be able to do the following. In this case right here, we can write this following mass ratio. For the molar mass of calcium fluoride, in this case right here, will then equal to 78.08 gram. 78 gram of calcium fluoride. And the molar mass of calcium is then equal to 40.08 gram of calcium. Did you notice how these two conversion factors right here are the same thing? So here in this case, if we were to convert 78.08 into 100 gram, then 40 will then become 51.33. But ratio-wise, they are the same thing. So basically, the percentage by mass as a fraction, it is very, very much similar to the mass ratio. And similarly, this would be the percentage of composition of calcium fluoride. And that is very much similar to how we would write this as a conversion factor using the mass ratio. And again, the molar mass of calcium chloride is 78.08 gram of calcium fluoride. And the mass of the fluorine, each fluorine is 19. So this is basically 38.00 gram of fluorine. And again, these two conversion factors right here are the same thing. In the case of a percentage, then the denominator is 100. And if we were to take 78 and convert this into 100, then 38.00 would then become 48.67. So again, they are the same thing. So the percentage of composition and the mass ratio that we have learned already refer to the same thing. And they basically show the relationship between the mass of an element in the mass of the compound. So here is an example of how we can use the percentage of composition or the mass ratio to do calculation. How many grams of fluorine are in 216 grams of calcium fluoride? So if we have 216 grams of calcium fluoride, how much mass of it would then be the mass of fluorine? That's what this question is asking for. So in this case right here, we can either use this conversion factor right here, either this one, the percentage of composition, or the mass ratio to be able to do this calculation. And now let's try this example on, in fact, this conversion factor right here. So in this case right here, starting from 216 grams of calcium fluoride. And now first, I'm going to try solving this by using the percent of composition here at the conversion factor. For every 100 grams of calcium fluoride, there will be 48.67 grams of fluorine. So that is how we use the percentage of composition of fluorine as a conversion factor. And this will then equal to 105 grams of fluorine, rounding to 3 sigma. Now similarly, we can also solve this problem right here by using the mass ratio at the conversion factor. And this is how we would set this up. 216 grams of calcium fluoride. And now, the molar mass of calcium fluoride is 78.08 grams of calcium fluoride. And the molar mass of fluorine in it would then be 38.00 grams of fluorine. And when we apply this math, the two answers would be the same value. So it does not matter whether we use the percentage of composition or the mass ratio as the conversion factor. We should still be able to obtain the similar answer. And now let's try another example involving the percentage of composition or the percentage by mass as a conversion factor. So example number 3. The FDA recommends that adults consume less than 2.4 grams of sodium per day. How many grams of sodium chloride can a person consume and still be within the limit? So now let's solve this by using dimensional analysis. So in this example right here, the starting unit would then be 2.4 grams of sodium per day. And the wanted unit would then be gram of sodium chloride per day. So our goal is to convert between the gram of sodium into gram of sodium chloride. And we will then see that we can use the mass ratio or the percentage by mass if that information is readily available for us to solve this problem. And in this case, we don't have the percentage by mass of sodium in sodium chloride readily available. It would then be easiest for us to use the mass percent or the mass ratio. So in this case, starting with 2.4 grams of sodium. And we will then see the molar mass of sodium is 22.99 grams of sodium. And the molar mass of sodium chloride is 58.44 grams of sodium chloride. So that's how we can use information right here as a conversion factor. And now gram of sodium cancel out, and we'll be able to obtain the final answer. And the final answer would then equal to multiply by 2.4 equal to 6.1 grams of sodium chloride. So that is the amount of sodium chloride that a person can consume and within the FDA limit of having 2.4 grams of sodium per day.